Okay, this one is slightly harder to film just because of angles, but just so you know, I've got a bit of paper here. I have my, not sure what this is made of actually, could be plastic, feels kind of plasticky. Let's just pretend it's a glass block because the same thing will happen. Glass block on my piece of paper. Then just show you the equipment I've got over here. This is my ray box, so light will come out of this, and I use this to slot in so that I get only one beam of light. So I'm just going to put that down and turn that on to show you, so you can see that beam of light there. I can just move that around. For now I'm just going to turn that off. So this one's about refraction, and just to kind of prove it to you that this happens. So first I'm going to draw around my block. If you do this at school, you should do it in pencil. I don't have any pencils on me, I'm afraid. Oh, mess it up a bit. Doesn't have to be the most accurate thing you've ever drawn. It's not a bit of artwork either. Just get around there. So if I remove that, I've still got the outline of where it was. So I'm just going to put that back in the right place. Okay, lovely. So now I'm going to turn on my ray of light. And I'm just going to make a note. I've deliberately not got it straight on. I've got it at an angle to the block. So this is not 90 degrees over here. So I'm just going to make 2 points along my... try not to... Right, just a little cross there. And just to make sure you can see it, I'll do one there. And I'll do the same on the other side. So... got one here and one there. Okay, I'll just do that a couple more times. I'm going to try and get it straight on this time, or as straight as I can. And the same the other side. There we go. So I've made my second point there. Just lift it up so you can have a look from above. So you can see I made my points on the line here and here. And should I do one more? Why not? So let's move it. Let's move it over here like this. Point there. Point over here. And then here. And here. So sometimes you can see the ray of light inside, but in this case you can't. Now I'm going to turn off my light. I'm just going to provide us with a bit more light in the actual room. I can remove my glass block now. I'm just going to use a ruler to join these dots up. Now, remember, this is the incident ray, i.e. the incoming ray, or, you know, the one we're deliberately shining on the block. I'm not going to do it through the block, but I'm going to join up these points here. And then I need to join from this point to this point. So in this case, okay, nothing that interesting has happened. I've just shone a light through something transparent and it's just gone straight through. But I'm hoping for the next ones. So this one here, let me just turn that so you can see. There. Oh no, I've not drawn that very well. Nope, not even drawn that very well. There we go. And again, I want to match this point here to this point here. hopefully you can see that that is not just a straight line. The light has actually bent, okay? So the light has bent as it enters the block. In a second, I'll draw the normals for you to show you exactly what's happened and what a normal is, in case you can't remember. But let me just do my last one. There we go. And over here. And let's match up this point. And again, that's actually not gone straight through. If you want me to put the ruler there so you can see, if I continued this line over here straight through, you can see that's a massively different angle. Same with this one. If we look at it from the left, if it went straight through, you can see it would follow along that ruler, but it's actually bent like this. So I'm going to draw my normals for you. So those are my imaginary lines that you draw perpendicular to the surface where the incident ray hits it. So that's quite a mouthful. So essentially where my incoming ray is, so here, I need to draw an imaginary line, but I'm going to draw it so you can see it, at 90 degrees to the surface. So it's not 90 degrees to this ray of light, but 90 degrees to the surface where the ray of light is hitting. So I'm going to draw it as a dotted line. Let's move this a bit closer. Hopefully you can see a bit better. Now, I am not using a protractor. It would be better if I did. So I am kind of approximating, but that should be about 90 degrees. Is that in focus? There. And I'm just going to quickly do them for the other ones. So where it leaves as well. Okay. Now for this bottom one, you can see that I have deliberately drawn it at 90 degrees, therefore the normal would be along the incident ray, and that's important. I'm trying to make that thicker so you can see. Okay, so move some things out of the way. Can hold it now. So over here, my ray of light has come in, and if I continued on with this line, sorry, I'm not really focusing it very well. If this continued in the same direction, it would be about here that I'm tracing with my pen. But what it's actually done is it's done this line here, and it's bent towards the normal. So it's gone more towards the normal than it otherwise would have done. And that's because the light has slowed down inside the glass block. So we should see the opposite happen over here. It's going from glass, just write glass up here, air and air. So over here, it has, I'm looking at the wrong one, this one here. It would normally go, it would normally go over here, but it's bent away from the normal because it's gone from glass into air, so something more dense to less dense, therefore it's sped back up again. And you can see this with this one up here as well, and down here. I won't draw it for you though. And then the bottom one, slightly different. That is at 90 degrees to the surface, so it is actually going along the normal, and it's only in that circumstance where the light does not bend. So because the light is hitting the glass block at 90 degrees, it will just continue to go straight through without bending. Okay, so that's just a starter of refraction.